Welcome to Section 3, Part 2. We're going to crack straight back into coding our player pawn, starting with a template for our modifier inputs. I'm going to create another template here to handle the modifier inputs. They're all going to be the same, but we're going to pass a different modifier key to it. So set up a template here with that struct, pass in, we'll create, and it's going to have each modifier key in it. And the variable, and this will be, we'll call this T variable, and that'll be the actual variable in the struct that we want to set. Call this process. We probably should mention the modifier a action. The action. Sorry, the bay of the actions, whether the modifier is pressed or not. It's this. We're passing this. Oh, sorry, input ones. And we've got the struct. And we have reference to our struct. And then we've got our variable. This is going to be a pointer to our struct, pointer to the member variable. So in this template, we just want to check that the input coming in is actually a boolean. We haven't messed up and we'll do this with all our inputs. We just want to ensure that the setup of the input action is correct. We're not passing in like a vector when it's meant to be a boolean. That's how we get the type, and then we'll just compare that it's actually the type that we're after. So there are all the types there. Got the different type of vectors there and the boolean. So if that's the correct input, then we can go ahead and update our struct to update. The variable in that struct that we want to update is the member variable we passed in, and it's going to equal whatever the input action value is. And this is why we need to check, because we actually need to get it as a type. And then we're going to call that update modifier function that we defined it up the top there. So just to show you how this works, in our modifier functions, we're going to call that templated function, pass our input action. We're going to need the struct, and we're going to need some data. So let's create a data class, just a file. And this will be our RTS Player data types.h. We're just got to include the generated data types. Go, and then we can put our struct in. Go, and this will be, I'm going to call this f modifier key types. Key type. We're going to have a type for each one. This is just going to be our bool setting here. So roll, need 3 more for each of them. So this will be the alt, the shift. But this is just so we don't have to have separate booleans and set them and carry on. We can just pass it around in a struct here. And now the other struct we need is for our actual modifier keys, what keys were pressed, and pass it around. I'm actually going to put this in RTS core because we're going to pass this to other classes and we want everyone to know about it. I'm going to come into core data and then data types in here, and it's going to be an enum, so I'm just going to put it under here. It's going to be just input modifier. You got to be careful with the naming of this because there is other classes. I think there's an e-input modifier, but I found the e-input modifier key used anywhere. We want to make this class. So the first one, I think I mentioned it in the other video, that we want to have something like that's default or not set to anything, and that's so no modifier is it. And then we've just got all our types. So they're the standard ones, and then we've got combinations. So we're going to have shift, control, shift alt, space. And then we're going to have the same for control here. Going to be control alt. We've already done control shift, so we don't need that one. We do need control space. And then for alt, I think we just need alt space, because the rest are covered there. So we've got shift alt and control alt. And then for space, we don't need any additional ones. They're all covered there, I think. Yeah. So alt space, control space, shift space. It's going to get crazy if you add more modifiers, but you get the idea. And then we're just going to cover I don't know if you're going to use this in your game or not, but we'll put it in here so it's there. This is so you can hold 3 keys at once, and you can press, what's this one? Control, Shift, Alt, and 4 is a key, something like that. Shift ones, Control, Space, and Shift, Alt, Space. And then, it should only need one more then. Would be Control, Alt. If I've missed a combination, let me know, but I think that covers them all. In our player port, we're going to add a variable here or an actual modifier. So put underneath the modifier section here, property, and it's, we didn't put a, go back to here. I'm going to put, that would have solved the name problem, but RTS core input modifier. Put a definite unique name there. Just call this modifier. And I want, so you can see here it's looking, I think it does need RTS core to be in the public section. So I'm going to include the data types.h from RTS core, and it's going to update the build there. So once it in. So there we go. And we have the include for the core data types. I want to show you the modifier setup. Oh, we need to create our struct, sorry. We need a, this will be a RTS. Input the prefix. Makes the names a little long, but if you're using the struct or the enum somewhere else, you know exactly where it comes from and you can find it if you need to add to it or change it. And this is going to be our modifier by key types. To include the data types from RTS Player. So now in our modifier setup here, this is where we pass in that struct, modifier key types, and then we pass in a reference to the FRTS Player modifier key type, which is the struct, and we pass in the variable that we want to update. So what's this? Is alt, so yeah, be alt. So now this will be that templated function we created here. So it's going to get the input action that comes through when you press alt and run this update modifier function. And we're going to do that for each of our modifiers. So you can see how it's sort of beneficial. I mean, we probably don't need to pass in so now we just need to change these to whichever ones they are for. So that'll update our struct with all our modifier inputs, and then the update modifier function here is what will set the modifier key input, the modifier key input here, whether it's a combination or a single or none. So let's do our update and set modifier functions. So the update modifier is going to call the set modifier, and then it will pass the actual modifier value, so our modifier variable, onto the input system, wherever that's going, and that's going to be an interface, so we'll come back to that. In the set modifier, this is where we need to go through our struct of the Boolean values there, all these, and determine what our modifier actually is. Let's go on this one. So we're going to need our modifier key types. Copy that just a bit. We're going to check, first of all, is it shift. So what we'll do, we'll set these up first. So we'll check each one. So we'll go control next. There's a little bit to this. It's just a lot of if statements really, but we'll do alt next and then space last. And it makes a difference what order you do this in because it's the way we set up the values. You'll see that in here, shift will have the most to do. So our modifier, first of all, if it's entered this, then it's definitely going to be shift, right? So we're going to set the RTS core, wasn't it? Input modifier. I'm going to set it to shift, and we can rinse repeat this into each one. And now we need to, so if shift is true, then we're holding the shift key, but now we need to check if we're holding other keys as well. So, because all these if statements will return. For example, if I'm holding shift and control, I'm going to come into the shift one and I'll do all the checks here, then I'll return. So I need to check if control is being set in here. And this is how we get the combination. We're going to do some if statements. So if it's control, now, so when you do an if statement, you don't need the brackets. You can do them in single lines, and I'm going to do single lines from here. It's not really the neatest thing, but it's just going to be so many of them. It's going to be easier to read, I think. This one will be shift control. So just to explain before I really hook into writing all this, the way this will work is if shift's held, then we're into here, and if it's just shift, then that's fine. The modifier will be set to shift, it'll go through all these checks and it'll all be false, and then it will return, and modifier will be shift. But if you've got shift and control set, then it's going to come into shift, then it's going to check this and go, oh, control's selected as well, so we're going to set the modifier to shift and control. And we're just going to rinse repeat this for all the combinations that we've got. So go. So now this one we want to check for the multiple keys down. So we're going to check control and another value. So then this one would be shift, shift alt, shift control alt. Right? Yeah, that's right. And then there's going to be two more of these. Control space. So that covers all the combinations that involve shift. Like this one. You can see here we don't need to check any of the shift, like so shift and control doesn't need to be in this one because it's already covered here. It'll get picked up there. So now the next one that's not covered is control and alt. And then for the last one, there's nothing left to check because space has been checked against everything here. So shift space, control space, we've got alt space. So we just need to check if it's space on its own. And then the last one is if it gets through all of these if statements and gets to the end, and there's no modifier being held, is there? I think it's probably a good time now to set up this interface that we're essentially going to use to send input controls around. And we're going to do that in core, obviously, because it's going to be used by whoever. And by whoever, I mean whatever plugin. Create an interface. It's going to be core input interface in framework interface. Now, one thing you need to do with plugins is you need to copy this API. So this will give access to the actual interface between plugins. The API gives it like a reference access. I don't know the ins and outs, but I know that this is needed to be able to use an interface between plugins. So in here, any functions that we want to send across. So for example, we're going to send across, I know at a time, that we're going to send across our select and command functions because they're going to get handled. So selecting and commanding is to do with entities, AI and stuff. So we're going to have a plugin called RTS entities later, and that's we need to send those commands to that plugin. So for now, we're just going to have abstract implementations. And we'll do one for modifier. I just included that data types. And that'll do for now. We'll add anything else we need later. So now back in our player pawn, send this to wherever it needs to go. We don't really care now, right? We're just going to throw it at the interface, and if the interface is not implemented, that's someone else's problem. So, well, yeah, problem, but anyway. I'm just going to check that we've got a reference to our controller, because the interface will be implemented on the player controller, or potentially later on an AI controller, like an AI player. So that's included the interface. Interface. There we go. We've sent the modifier key that we've set for our input here. So when we press spacebar, for example, it's going to go through, set the modifier to space, go through and set the modifier on our player controller. So I think it's time now to do our input, our controller's inputs, all these things here. So it's going to start with move. Most of them are going to need to check, definitely probably for input data if we use, so that'll be if we're using these sort of settings, we'll need to check that that's valid. Point out to that data is valid, and in the move we're using the spring arm, so checking that. Now this is that ensure that we need to do, so we're doing that in our template, sorry. So we're doing this check here, copy this time. And it won't be a boolean, it will be, I'm pretty sure it's axis 2D for move, moving in X, Y. So we're going to get the value. By the speed, how far we want it to move. And I'm going to use the modifier here. So this, just so like you can hold shift and it will, move faster. So shift. Checking our input data, we're getting our move speed, and if it's shift, then we want to go say double the speed, and if it's not, then we just want to go whatever. Now we need a variable for our pawn location. I'm going to put this under private down here. I'm going to do another one for rotation. And this one will be our zoom. So for rotation, we're going to need the pitch and the yaw. Right, so go back, move. At our target location. What that's doing is that's converting the direction the spring is facing for rotation and moving the location, the value that's coming in, so the axes that we're pushing forward on, so WASD, and then applying that to the speed, so that just magnifying the value coming in by speed. So you press W, it's gonna, send 1, say, and it's gonna times it by the speed. So it's going to move it on the X value, say 1 times speed. If the speed is 5, then it's going to be 5 instead of 1. Now the other thing we want to do is we just want to move the target location. So if you're using flat terrain, it's not going to make a difference, but if you're using terrain up and down, then you don't want well, it depends on what you want actually, but the line's going to map to the terrain. So it's going to create a function for getting the terrain position at the new location. I'll just put this up here. And rather than just returning a position, I'm going to put in a reference so I can just update it. Where I can keep it also. So this is just going to do a line trace down. First of all, we'll move the start up high, and then we'll line trace back down to the terrain to get the hit position on the terrain. Depending how much you train down, you may want to change this amount, but 10,000 is pretty, I've no problem with it ever. Now we'll just do a trace. So I've done the wrong struct there. This should be a query for collision parameters usually like if you add like ignore yourself as collide with yourself, but we're actually going to change the trace channel so it won't collide with anything but the terrain. The player camera doesn't care about objects in the world, you just want it to run along the terrain smoothly. And we're just going to return the impact point, so the position we hit, and that's returning through reference, so we just set this and that goes back to where it's called from. And so now we this channel here, throughout all the plugins, if I've got any sort of static values, they're going to go into the static game data class like this. And I think most of them I'll just keep in core, even though I'm working in player pawn here, I'll just keep them in core because they're just a string, it's not a massive deal. I might put this one at the top and it's just going to be don't choose the engine one. I made that mistake. Yeah, and that'll be that. So I'll explain this more when we set it up. So in the editor, we have to actually add this trace channel. But when you, I'm going to include the static game data. When you add a trace channel, there's basically these preset game trace channels. You've seen them all there. Like, so they're all there, like presets. 19 of them, or no, 18. So each time when you add a trace channel, it'll take one of these slots as your custom channel, and that's all we're pointing to. So rather than mistype this, I've got a nice neat name for it here that I can use, and that's all I'm doing. That's why that defines it. So I could paste the ECS game channel in here, but I potentially could mess it up, and it's not clear as to what channel it actually is. All right, so we've got that frame position now, so I'm just going to pass through my new target location to shift it to the terrain. That's the move function done. One down. Alright, let's do some copying. I don't think we need a references bring it. Check what we could do. We just move this. Do that. So then this one is a 1D, I believe. And we need to do similar things. So we need to get speed, so like this, but it's going to be rotation speed. So we'll rotate faster if we're holding shift, is the idea there. And then we want to get, sorry, this is the look, isn't it? Not rotate. Sorry, so we'll still use rotation speed because, so this will be where we can hold middle mouse and pitch up and down. So change the angle that we're looking at towards the ground at. So if we're holding shift plus middle mouse, then this will go faster. That's what we want. And now we need to set the new pitch. So it's going to be similar to this, but it won't be a vector, it'll just be a float. So axis 1D is essentially just a float. And we're going to reduce the speed down, otherwise it's just too crazy. So we're going to get the speed that we just calculated above and reduce it down to 25%. And you could make this a variable and put it on the data if you like, but we've got that as a variable and I think it works for me anyway. So we had that pitch variable that we set up. We now need to assign that, and in the input data we have a pitch min and a pitch max, and this is to stop the camera tilting over upside down, so like going all the way over, call it 90 degrees. Yeah, So we're going to clamp it so we can stay within our pitch min and max. So it'll be pitch plus the new pitch that we just calculated, the value. So we want to clamp to pitch max first, and then pitch min kind of backwards. So this new pitch now, we need to convert that to a rotation. So we're going to go to a quaternion. And to be honest, I'm a bit iffy on all this, but I know this, this works. So we're first going to do the yaw rotator. So then we'll do the pitch rotator. Back to an F rotator so we can use it. And then our new rotation, we just need to zero the roll, so we somehow inherited some one. And then we're going to apply that final rotation to our target rotation. So zoom, we're going to have the same. Be a 1D as well. I'm going to give this speed here. Same again. Going to be zoom speed. Then we're going to assign our target zoom. Do a clamp. We've got the min and max zoom. This will be the value. So, actually, we'll do a times speed. That will add the speed in, and then we need our clamps. So it's going to be data. It's going to be min zoom. Yeah, min zoom. This is the min zoom. We did. There you go. Start. Alright, our rotation. Going to be another 1D. Copy the speed again. Copy the one because it's exactly the same. And I'm also going to copy this because I'm going to reduce the speed down as well. And then rotation is going to affect the yaw, so I'm just going to add to our yaw. The rotation. A new rotator, so I'm going to add the pitch, add the dot yaw. I'm going to add the new rotation. Sorry, the value. So that's the new yaw that we're adding, and there's no wrong. So now we're onto the select and command, which are all going to use that interface. Come down to where this interface, and I'm going to grab it, plug it in. I'm just going to do this for all of these. And this will be select. Alright, so I think that's all our inputs done. Now we need to update the values based on what we've calculated from the inputs. So let's grab this. Just do some comments here. This will be the born in desired, the zoom camera desired to target zoom. Move on to target location. So accurate. And this will be the rotation. So rotate camera to right, the first one. We need to calculate location. So let's call it interp location. Interp. And we're going to get the current location of this pawn. Get back to location, to the target location, applying delta time. So this is going to calculate how far it's moved in the last tick. And so it's moving from the current location towards the target location, but only the amount it should move based on the speed and based on speed and time and how much we smooth it out. So now this interp location is the location we should be at this point in time during this tick. So we're just going to set back the location to that point. And then we can do the same for zoom. This is going to be a float interp. Spring arm length. So it's the current arm length, sorry, and this is going to be the target zoom. We'll do the same time and the smoothing. And then we'll apply that length to the spring arm. And for the rotation, same again. Do a rotate tour. Interp 2 for rotator interp 2. The current rotation of the spring arm, because we're not rotating the actual pawn, we're rotating the spring arm around the pawn. That's why before we got the spring arm rotation here. So we're checking which direction we're facing based off the spring arm and translating that to, so we can translate this direction to world space. So our target is our target rotation. I'm going to apply the same here. And apply that to the relative rotation. Now, we come back to we haven't actually done our setup of these functions. So we created the functions, went on and implemented them, that's fine. So let's finish that off now. So there's a couple others that'll be trigger only, so we can just copy this one. We've got move, we've got look, we've got zoom, we've got rotate. Look, zoom, rotate. And then we've got our select and command functions. They're a bit different. So we'll copy one of these. But this will use a different macro. So we want the 3 different functions, remember, we pass through in the template. So we want the what we call start trigger complete, and then we're going to want 3 separate functions for the. So this will be select start, and this will be select the first one. And then we'll duplicate this twice. And this will be select hold for the middle one. And select end. So what's going to happen there is when we start the press, it's going to call select. When we hold it, it's going to call the trigger. And when we call complete, it's going to call end. And we want to do the same for the command. Now for our modifiers, the modifiers we have to call twice. So because the modifiers are hold toggle, what we're going to do is when we let go of the key, we're going to check it again, and which will set it back to no modifier. Or it'll set whatever the bool in our struct is. So if we're holding shift and we let it go, it's going to then set shift to false. That makes more sense. Let's copy one of these. Change the template to trigger and complete. I'm going to want a second function. And this is going to be, like the first one, shift. So this will be input shift, modifier shift, we called it. And this one, it'll be the same function. So the first time we come through, it's going to come through, it's going to set the value in our struct to whatever this value is in the input action value. So the first time we come through on trigger, it'll be held, so it's going to be true. And then the second time on complete, we've already let go, so there's going to be a 0 input, it's going to be false. Otherwise, if we just set it to like trigger only, we'd press shift, And then when we let go, nothing will happen, it'll just be on forever. So let's do that for all our modifiers. So that gets our inputs ready to go and linked up to our functions. We'll end this part here. In the next part, we'll look at implementing the input mappings and then essentially moving on into the editor and setting things up.